Welcome Year 8 to your first topic, tectonic activity. This is our topic now for the next 5 weeks, and lesson 1 is structure of the world and plate boundaries. So for this lesson you will need your fact booklet, pencil, ruler, pen and paper. Your first activity is a quick fire round. So this is where we will have 5 questions at the start of each lesson. If you pause your video here, then you can have a go at these 5 questions, which are based on prior knowledge from Year 7 and primary school. So planet Earth, also known as Gaia, the world, the blue marble, or Planet Awesome, is part of a solar system of 7 other planets. So there are 8 planets in total, with one small dwarf planet known as Pluto. Earth also has many other planets as well within its galaxy, which is known as the Milky Way. When Earth formed, which was about 4.5 billion years ago, it was a really explosive, hot and gassy planet. But it soon began to cool, and this meant it became wet, and it rained for thousands and thousands of years, which is where our oceans appeared. Small islands also began to appear as well, and eventually these all joined up to create one giant landmass called Pangaea. Eventually, Pangaea split up into the 7 different separate continents that we know today. If you pause your video here, see if you can name all of the 7 continents. The Earth is made up of 3 quite distinctive layers. So right in the middle of Earth is the core, which is split into the inner core and the outer core. The inner core is solid and the outer core is liquid, but both are made from metal. The mantle is also split into different layers. You have your upper mantle and your lower mantle. In total, it's about 2,900 kilometres thick, or 3 times the length of the United Kingdom. It is made up of heavier rock. The upper mantle is hard, whereas the lower mantle is softer rock, hot melted rock, a bit like toffee. The last layer, the surface of the Earth where we live, is the crust. And it's the crust and the upper mantle that make up our lithosphere. The Earth's crust is also divided into oceanic crust and continental crust. The oceanic crust is what is formed underneath our oceans, and the continental crust is the land that we live on. If you pause the video here, do you think you could describe the difference between oceanic crust and continental crust? Pause the video here and use a pencil and a ruler to draw out the table, and then watch the video for the next few slides of information on the different plate boundaries. You may want to pause the video as you get to each different plate boundary. What we would like you to then do is to read the information on the screen, listen to us talking, and write down the type of movement the plate is doing, whether it forms earthquakes, volcanoes, or mountains. So these tectonic plates move because they are large slabs which sit in the Earth's crust and upper mantle called the lithosphere. They are solid and they float on soft, hot rock below. They move because they are dragged along by powerful hot currents known as convection currents in the soft, hot rock. They move just a few centimetres a year, but it all adds up. So for example, India has moved 2,000 kilometres north in the last 70 million years. This plate boundary that you see here on the screen is called a destructive plate boundary. This is where you have oceanic crust subducting down underneath the continental crust. Where the 2 plates meet, there is lots of friction, which causes the earthquakes. But also where the 2 plates meet, it gets really hot, so the rock inside of those plates start to melt. and it forces and pushes its way up through, forming a volcano. But also at the top on the surface, this rock is also being squeezed. So it squeezes upwards and forms our mountains. Conservative plate boundaries are where the plates are sliding past each other. Both plates are moving in the same direction, but one plate might be moving faster than the other. So the result here is lots of friction being built up as the plates get stuck and then suddenly they release, which is what causes our earthquakes. But the rocks are not getting pushed downwards or upwards, and so there is no melting, so no volcanoes and no formation of mountains either. Constructive plate margins are where the plates are moving apart. So this is where perhaps the heavy plates are pulled apart by convection currents in the soft rock below them. And where they're pulled apart, the liquid rock, the magma, will rise up to fill the gap. And if this was under the ocean, underwater volcanoes would form. As it's in the ocean, it cools and solidifies, and therefore you also get mountains. And the long ridges of mountains form under the water. The plate movements also cause earthquakes. So where the plates move apart, you get earthquakes and mountains. Well done, Year 8. You have now reached the end of Lesson 1, Structure of the World and Plate Boundaries. We hope you've enjoyed this quick lesson, and what we would like you to do now is refer to your fact booklet and try to learn these 3 facts that are for the Week 1 lesson. You'll be quizzed on these in Week 2. See you then.